I have the pleasure to being here with Dr. Erin Elliott, and she's an expert in optics who actually is native of North Dakota, and she first majored in physics and astronomy in the University of Minnesota, and then received her doctorate in optical science from the University of Arizona. And she worked first at Ball Aerospace and then at the Space Telescope Science Institute, just developing the software for the alignment of the mirrors of the James Webb Space Telescope. And after taking a short break, then she moved to CMAX, now Ansys, in different positions. And now Erin is a principal research and development engineer who, needless to say, has a very exciting career. And we're talking with her today here. And good morning, Erin. Thank you so much for being here.
Good morning. No problem.
Even though Erin grew up in a farming community in Minnesota with good schools and she was good in math, she feels that her family had an important role in helping her to become a scientist because they love to read about everything, a habit that she picked up and eventually influenced her.
So, one of the things that really influenced me, and this is funny, is just reading a lot of National Geographic. It just really got me hooked on science. And at a pretty young age, like seventh grade, I read this article about stars having lives. And
Oh,
it just kind of blew my mind. I was like, stars have lives? Like they're born and they age and they get old and they die? This is incredible.
however, Erin accepts there might be other helping factors.
I had an uncle who was a radiation physicist in the hospital,
Oh.
and an aunt who did optics at 3M, an aunt and a cousin. So I had some exposure to physics a little bit, and that helped me, I guess, feel like it wasn't impossible to do.
Yeah.
But yeah, so I did physics and astronomy in my undergrad.
And then you decided to do your PhD in optics. So you were saying that your aunt and it was in optics. So
I think a lot of these things are a little bit random when you're young because we don't know very much, right? We're just trying things out. And I did work with my undergraduate advisor on putting a radio telescope on top of the physics building, and
oh, cool.
it never worked.
Well, but you tried the important thing.
We didn't get the antenna right. It never really worked, but we had a lot of fun, and it kind of drew me into the world of astronomy instrumentation. Yeah, and also there was some practicalness to it. Like farming, growing up in a farming community, there's not much money around, and it was important to me to be able to support myself. Even at that age, I knew that that was important. So instrumentation and optics just seemed more practical and as well.
Yeah, that sounds pretty good. That thing about that you say that building things, and even if you did a very important thing but it didn't work, I think that was a very exciting experience. So
And I also during undergrad, I did an internship at 3M, and that internship was so interesting because, like a lot of people, I think I thought that everybody in science was like a genius like Einstein, and nobody needed help and nobody needed to study and learn from other people. I thought it was just some magical thing that you're born with. And working at 3M, I'm sure they would be surprised to know, convinced me that not everybody in science needs to be a genius.
definitely, yeah.
They're just trying to figure out the problems too, which convinced me, hey, maybe this is something I can do. I can go in and try to figure out a solution.
Yes, and actually, I met you when you went to work at a space telescope with the James Webb, which you did great things in there. So why don't you explain what was your involvement with James Webb?
Yeah, so I mean, it's important to say that thousands of people worked on JWST, right? And the different aspects. And so I was just one tiny, tiny part of it. But I was working at Ball Aerospace at the time, and it was really fun because I worked with the team that developed the alignment software. And it was a really challenging, really new set of problems. So there was just a ton of creativity and exploration that needed to happen to figure out how we were going to do that with the constraints that we had. So it was a really, we also had to provide some hardware for the near cam camera to support the alignment. So overall, I think I was there 10 years or so, and it was just a very formative experience because I was learning things every day.
And if I remember correctly, you also use the same software for with the alignment from the company that you are working currently, right?
You know, it was, again, JWST was a huge project, and it really pushed simulation technologies forward. So all of the simulation tools that we were using were really being pushed to the edge of their capabilities.
Okay.
Yeah, including the ray trace software. So the Zemax and Code 5 were the dominant softwares at the time, and we used both. And Zemax had some flexibility that I needed to really let me work more easily with these segmented systems. And they spent a lot of time making their GUI kind of usable and accessible when they first started. And so I was really impressed with that. And later, when I was searching for something non-hardware to try, they were hiring. So then I got on board at Zemax.
And when we think about, for example, optics, we don't think about what you are doing. I mean, why it is important, what you do as a researcher in the company with optics?
Yeah, so okay, so JWST is an infrared telescope. It had 18 segments. The segments need to be aligned. And a lot of people think about optical engineering as the design part, but in fact, I keep telling people it's just this tiny, tiny piece of what optical engineers do, right? Because we have to get the whole thing put together and operating and meeting the performance specifications. And that's by far what you spent the most time on. So everyone, I mean, so many people worked with optical software on that project, but the part that the reason I was using it was because we built a testbed telescope with flight style actuators on the mirrors to move the mirrors to explore all the alignment steps and make sure that they all worked. And especially in like the worst case scenarios. So we had everything connected together through LabVIEW. So you could run an alignment experiment in Zemax.
Mm-hmm.
And then we had another black box tool that we used, and we could go and actually try it in the lab, order the equipment to run the same simulation so that we could see if it worked. Yeah, it was amazing. And none of that really supported all the other stuff people were doing, right? Like building and testing the mirrors and all of that. This was really just for the alignment simulations and proving out the software.
That's a really and really very important, right? Because if you don't align them, you don't see anything.
Yeah. And I heard from the team that they used one of the workarounds I put in, which I'm really proud of.
Oh, that's wonderful. Well,
Yeah.
that's I just say you have a big team of people working in the project, just supporting each other, which is very important.
Yeah, teamwork, teamwork in science is so important nowadays. There's nobody really doing things by themselves in a garage anymore, right? Like having that big team of people and the experts that you need and having good communication between them is really integral to being a successful scientist now.
Do you feel that you fit pretty well in those teams, or you work in different companies? So were there hurdles that you had to deal with?
Yeah, there definitely were. I mean, there is for everyone, but I just had so much to learn so fast, and I found that people did a really good job of supporting me and answering my questions and debating things with me. Um, that all went really well. And then all the companies I've worked at have really been fairly male dominated.
Mm.
And so it was in a way, it was handy to be a woman working there because they tended not to forget who I was.
Yeah, that was good.
But I did find that it was a little more problematic as you become more senior. It started to feel more problematic a little bit because sometimes if you're running things, people don't assume that you're the one that's in charge, or that they assume that maybe you don't have the leadership or the status to make decisions. And
Mm-hmm.
occasionally that was a problem. Like I was pretty good at letting people know that I really did have the power to make those calls. But you did have to remind people sometimes, like if you looked, I didn't look like the stereotypical scientist. I was female, and sometimes in particular, I looked too young. Um,
Mm.
so I found that I had to be pretty assertive about letting people know what my qualifications were and what my responsibilities were, just to make sure that they knew that I really did have the power to make a call or be in charge or make a decision.
Yeah, and you said that to be assertive, but I think that when you started, usually, for example, we are afraid as a woman, and even boys too, we are afraid to face sometimes, to make mistakes, to
Yeah.
get into a career. And I mean, you said that they supported you when you started. So I think that means that people, you should not be afraid to take these careers on engineering like you did, and then it just learn and work with people and learn from other people, right?
Yeah, that's right. I mean, the learning from other people is key, and I think that our industry is quite good at that part of it. Like we're pretty good at nurturing people and helping them. And when you're a young engineer, there's a lot of fear, I think, that you might, like you said, that you might mess up, or that people might yell at you, or if you have a problem that you shouldn't figure it out, bring it to your manager. And one thing that's always true is everybody is just people, right? And management is usually thrilled to hear that there's a problem and you have an idea for how to fix it. You know, like they just want to know what's going on and how to help you get your job done in most cases. And so you can be quite vocal about what are the resources we need to do this? What's holding us back? There's a kind of a fear of talking about any of that kind of stuff, I think, when you're a junior engineer, but people appreciate it if you're communicating clearly about what's happening and what you need to make it work.
And that's part of you, this you say, you being assertive, be confident of yourself, that you can address problems, right?
Yeah, that's right. Our job, people think that we hang out being smart people or something, but our job is to go in every day, figure out how we messed up and how to fix it. Like, that's what engineering really is.
And that's what you do now with your position as doing research, right? You are trying to figure out problems and making things better.
Yeah, so now I'm in research and development at Ansys, who bought ZMax. So I'm still mostly working with ZMax ray trace software, but I'm also working with other tools. Um, and this position has been a ton of fun because so I get to do a lot of design work. Like optical engineers in the field need this tool, so let's sketch one out, try it out, talk to customers, see how it's going, and just develop these products. And it's just very fun.
That's good.
Yeah. One thing I really like about it is it's super creative because you're just starting from scratch, right? Like you're like our customers say they have a problem getting measured optical data onto the mirrors, and you're just starting from scratch. How do we address the problem? What's the quickest way to build something that we can prototype that they can try out? It's just super creative, which I find I really appreciate. JWS, the software on JWST was pretty creative at the beginning, but then as you get toward flight, it gets more hardened, right? So you're still using a lot of creativity in terms of how to solve the problems. But now I'm doing a lot of design, creativity and design too, which is really fun.
Yeah, I think that's important. Make it exciting for you, right? To work where you work now.
Yeah, something I've learned is that, there's so many different kinds of brains out there, and people really have fun doing different kinds of things. And it's interesting because I used to kind of agonize about what kind of job I should have, but in fact, it doesn't quite work that way. It's more like any job you take, you will find the things that you love and are good at, and you will pull those out of that job. You'll emphasize those in that job. And so I wish when I was younger, I had known that the particular job you take is not quite as important, because you tend to turn it into what you love if you have a little freedom in it.
And I think that in your position, you have a lot of freedom. I mean, I think that's great that you can do what you like. And talking about the not work, but what do you do in your during your free time? Do you have hobbies that you enjoy?
I really love my work right now, so I do a lot of work, but
I understand you. I'm me too.
maybe I don't know, maybe too much, I don't know. But no, I do have a lot of hobbies. I like to do road trips. So I take opportunities to take road trips whenever I can. We had a conference in Quebec City
Oh,
a while ago, and I drove up there and stopped in Sackets Harbor and some other, yeah. And I also play piano. I do quite a bit of writing. I actually do a lot of writing at work too, because we communicate with our customers a lot. So I do a lot of technical writing at work now, which I'm really enjoying as well.
and you took a master's in that, right? In
I did
writing.
not, I did not finish.
But you took the classes, some classes, and some classes help even if you didn't finish, I guess.
Yeah, that's right. The classes were really interesting, and something I learned is that I'm drawn more to fiction than science writing. I thought that science writing would be a natural fit for me, and I do enjoy doing that at work a lot. But I also have this kind of creative fiction side that I've really been having fun with. Um,
That's that's great. And you mentioned something that you love to work, and that's how you spend most of your time. And I think that I do the same. I said sometimes that I'm a workaholic, but there is nothing wrong with that because you're passionate what you do, right? And it's okay.
yeah, that's right. In fact, I think I was off for a year while I was taking writing classes and kind of trying to figure out what to do next. And somewhere in that year, I said to my family, I said, I really miss geometry.
Yeah, I understand you. That's very, yeah, that's
And
great.
my sister-in-law said nobody ever. I said,
You like to keep your brain working. I mean, to be active with your brain, creating things.
yeah, and I think that's again, like understanding what your brain is drawn to is so important, right? Because I really kind of enjoy that kind of spatial reasoning stuff. I really like drafting and drawing, and it makes sense to me that I was missing some of the geometry. There was a lot of geometry in JWST, and there's a lot of geometry in optics.
Math is beautiful. As I would say, math is beautiful. So geometry is more beautiful.
Really beautiful. Like, I mean, I know that not everyone sees that beauty when you look at engineering and math, but oh boy, I see it. It's like especially beauty is a really interesting topic, right? Because actually in engineering, you can look at an assembly drawing or even certain plots and graphs, and you can kind of see if they're right based on whether they seem beautiful. Like, especially hardware assemblies, actually, it's very strange. You can look at it, and if it's super ugly, there's usually some kind of technical problem there.
That's a good way to put it. That's good.
Yeah, it's underappreciated. It's underappreciated that like the beauty and the spareness of kind of minimalism can give you some hints about the actual engineering of something.
That's very interesting way to put it. That's great. So,
Yeah.
well, Thank you so much for talking with me and
Yeah.
talking about the interesting work that you do. And well, again, thank you.
Thank you so much. This was fun.